Hello, and welcome back to the channel Cosmos Deep Dive. Today, we're embarking on a journey to the very edge of what the Earth can endure. Our world is a breathtaking collection of contrasts. Think about it. Our planet is a swirling, dynamic ball of fire and ice, life and death. We marvel at the sub-zero silence of the polar regions and the supersaturated chaos of the Amazon basin. We've named the highest point, Mount Everest, where survival is a negotiation with thin air, and we know the deepest, darkest trenches of the Mariana, where the sheer brute force of pressure could crush steel. But there exists a location, an epic, scorched laboratory, where the natural conditions are so extreme, so far outside the comfortable zone of biological life, that it forces us to rethink the fundamental physics of survival. It's a place that pushes the very definition of a habitable zone. I'm talking about Dasht-e Lut, the Lut Desert, a colossal and remote salt desert sprawling across southeastern Iran. A vast basin nestled between the Sistan and Baluchistan and Kerman provinces. This isn't just a big, dry place. At roughly 51,800 square kilometers, an area larger than many European nations, it is the physical embodiment of desiccation. Lut's topography is deceptive. It sits at a modest average elevation of 300 meters above sea level, dipping to depths of 50 meters in its central troughs. Its geography is defined by boundaries: the Great Salt Desert, Dasht-e Lut, to the west, and towering mountain ranges that act as formidable rain shadows to the east. This geography sets the stage for the unthinkable. In 2005, NASA's MODIS, Moderate Resolution Imaging Spectroradiometer satellite sensor, recorded a number that shocked the scientific community: a surface temperature of 70.7 degrees Celsius, 159.3 degrees Fahrenheit. This was not an air temperature. This was the temperature of the ground itself, the highest natural surface temperature ever definitively recorded on Earth. Subsequent measurements, meticulously taken between 2003 and 2021, have not only confirmed this figure, but frequently highlighted the Lut Desert as the undisputed thermal champion. Let's be clear, this level of heat is enough to instantly kill most plant cells and rapidly denature, break down, the proteins and DNA of nearly all complex organisms. To understand how the Lut Desert achieves this thermal record, we have to look beyond simple geography and dive into the mechanics of heat transfer. It's a catastrophic synergy of three key factors: composition, atmosphere, and structure. Composition, the albedo effect in reverse. The surface of the Lut is not uniform beige sand. Critical regions are blanketed by dark-colored basalt and ancient lava beds. Dark surfaces, with their low albedo, reflectivity, are hyper-absorbers of solar radiation. When the sun's powerful energy hits these dark rocks, virtually all of it is converted directly into heat on the surface, rapidly amplifying the temperature to extreme levels. This effectively creates a massive geological heat sink. Atmosphere, the broken heat regulator. Water vapor is Earth's fundamental temperature buffer. It absorbs solar radiation and prevents rapid runaway heating. But in the Lut Desert, the average annual precipitation is almost negligible, less than 50 millimeters. This means the atmosphere is nearly bone dry, creating a clear pathway for solar radiation to bombard the surface without moderation. The natural thermodynamic balancing mechanism is disabled, allowing the surface to become brutally hot. Structure, the Kaluts and convection traps. The third factor is unique to the Lut: the spectacular wind-eroded ridges known as the Kaluts. These massive, streamlined sand and silt formations are sculpted by relentless wind erosion, particularly concentrated in the western sector. They can reach heights of 70 meters and extend over 150 meters. These structures, along with the vast reflective salt flats, playas, don't just shape the land, they shape the air. They help keep the hottest, lowest layer of air trapped near the surface, minimizing cooling via convection and ensuring the direct absorption of radiant energy remains maximized. The Lut Desert is, in essence, a giant, geologically designed convection oven. Given these lethal parameters, temperatures over 80 degrees Celsius, and absolute scarcity of water, you'd assume the Lut Desert is a completely sterile environment. But here's where biology steps up and delivers a profound lesson in resilience. Within the Lut's hostile depths, life finds a way. We encounter extremophiles, organisms, mostly microbial, that have evolved stunning, specialized adaptations to survive. These survivors fall primarily into two camps: thermophilic bacteria, heat-loving, and halophilic organisms, salt-loving, adapted to the high salt concentrations of the former lake beds. Scientific research, particularly sampling from deep within the basalt lava flows and under the salt crusts, reveals astonishing cellular engineering. These organisms produce specialized proteins and heat shock enzymes. These molecular components act like biological stabilizers, physically reinforcing the cell membranes and preventing the catastrophic denaturing, the unspooling and breakdown, of vital proteins and DNA structures under intense heat and desiccation. They keep the core cellular metabolism just barely ticking over. Biological diversity is, as expected, severely limited. You won't find complex flora or fauna, but you will find organisms like Deinococcus radiodurans, a bacterium famous for its resistance to both radiation and desiccation. Its secret? An incredibly efficient and constantly active DNA repair mechanism. Other cyanobacteria use unique proteins to regulate intracellular water potential, maintaining vital osmotic balance against the high salt and extreme dry heat. The Lut Desert is a living testament to the fact that wherever there is even the slightest thermodynamic or chemical gradient, life will exploit it. Beyond the terrestrial extremes, the Lut Desert holds a key to our future in space. For NASA and the Iranian Space Agency, the Lut is not just an Iranian desert, it is a prime Mars analog. The Lut's geology exhibits striking morphological and mineralogical parallels with the Martian surface. The ancient dried-up lake beds, the high salt playas, the layered basaltic lava flows, and the extreme arid conditions closely mirror the conditions we believe existed and possibly still exist on Mars. This makes the Lut an invaluable, accessible terrestrial testing ground. By studying the survival strategies of extremophile bacteria here, their tolerance for low water, high salinity, and high radiation, scientists can develop more accurate models for possible microbial life scenarios on Mars. We test our equipment, refine our search parameters, and hone our understanding of biosignatures in a landscape that chemically and structurally mimics the red planet. Furthermore, geological analysis of Lut samples has revealed chemical similarities to Martian basalt and olivine rocks. And in a remarkable find, a team of Russian scientists discovered an approximate 12-kilogram mass of extraterrestrial material, meteorite fragments believed to be about 4.5 billion years old, preserved beautifully by the desert's sterile, dry environment. The Lut is not just like space, it preserves history from space. Despite its brutal environment, the Lut Desert region has been a significant cultural corridor throughout history. Archaeological digs have unearthed remnants of ancient settlement, including the Nimrod fortress and connecting trade routes to historical giants like Uruk and Susa. These stone structures, water channels, and storage areas speak to the ingenuity of ancient civilizations who found ways to harness scant resources and survive in this harsh territory long before modern technology. The Lut Desert challenges us. It redefines the boundaries of life, demonstrates the relentless power of geological forces, and offers us a vital window into the ancient past of our solar system. It is a place of blistering secrets and untold scientific potential. The Lut continues to push the limits of what we know. If you found this deep dive into Earth's hyper-extreme laboratory fascinating, please like this video and subscribe to our channel. Your support is what makes new, scientifically grounded videos like this possible. Thank you for watching, and we'll see you next time. We would be grateful if you could like the video and subscribe to our channel. Your support makes new videos possible.